Good morning, and thank you for joining us today. It's a pleasure to have everyone with us. My name is James Lydon. I'm our channel account manager. So my role primarily is looking after the UK and Irish market. So it's great to have partnered with Kelleher's. We are really excited about things to come over in Ireland. We've not really done a lot in Ireland previously. It's quite a new market for us, so there's a big focus for us as a group. In the UK, we're leaders over in England. So yeah, thanks for joining, everyone. Nice to meet everyone. And we will get started. Before I start, I think attendees' microphones and cameras will be off. If anyone has any questions while we're going through the presentation, you will see at the top you should have the Q&A box. If you click on the Q&A box and type in your question, and then I'll come to the questions, possibly in between slides, or if not, we will come to them at the end. Okay, let me just get onto the right screen. Okay, so a little bit about Sunsynk. So the group, we've been established for more than 30 years. So we are a well-established company. We've been in the business for a very long time. Our first market was South Africa, where we still have, it's about 75% market share over there. So it's a huge part of the business for us. And, if anyone's not familiar with the power struggles in South Africa, over there, if you don't have, an inverter and batteries and PV, you've got a lot of problems. Daily they have what's called load shedding, where the grid operators there will move the power around different districts. A lot of it is planned. So yeah, if you don't have batteries over there, you're without power. So yeah, it's a big market for us. World leaders in inverters and battery storage. So Keith, who's our founding chairman, way back when, he's an electrical engineer by trade. Way back when, it was himself and a professor from a university. They actually invented the technology behind a bidirectional inverter, which is a hybrid inverter. So that sort of gives us that tick on, world leaders in innovation. Innovation is really important to us as a group. We've got a dedicated office in the UK, which has got our global R&D team in, where we, they're constantly looking at new products, market developments. So yeah, offices in South Africa, in the UK, where I am now. So we've got a 35,000 square foot facility in Widnes near Liverpool, where we keep most of our UK stock. Some of the sales team are here in finance, and then we've got two offices about a mile away. One of them is our global R&D office, as I just mentioned, and we've also got our global marketing and graphics department. Also in this building that I'm in is our tech support team. We've got offices in Hong Kong, Australia, Spain, America, UAE, Poland, Germany, and Netherlands. So as you can see, quite a big footprint. Over 970 gig of power installed globally. Internationally recognized brand. Probably the most important thing for installers is we have UK-based tech support. So you can say to any installer, what's the most important thing about an inverter brand? Someone will say price, but most of the time they will say good tech support. So we've been doing this for a long time. We've got a big tech support team based in the UK. So they're here to support you guys as installers. So, my recommendation to new installers is always, get the system installed, get it connected to the internet. And if it's your first install, just give our tech support team a call and just say to them, it's my first install. Can you remotely access it, and just sort of dot the I's and cross the T's and make sure everything's fine? Okay, so some of the key features of all of our hybrid inverters. So in today's webinar, we're going to look at the Acure, which is a brand new inverter for us, but we will also sort of skim over the classic range. So the key features I'm going to go through now, these are the same across the board. So whether it's the Acure or Classic range, it's the same. So as standard, very basic, but there's a Wi-Fi logger in every box as standard. Our Classic inverters, you can purchase a LAN logger. So if you do need to hardwire it, you can do that. And we also sell a GSM logger. So if you're doing an installation in quite a remote rural area where there's no connectivity, you can use a GSM logger. All of our hybrid inverters are IP65, so they can all be installed outdoors. We have a built-in UPS output. So some manufacturers will have an EPS, an emergency power supply. Ours is a UPS, so it's completely uninterruptible. So any loads that are physically connected to the inverter will remain powered if there's a power cut. So that might be, as simple as a double socket to give the end user access to power if there is a power cut, or you can wire in an essential circuit to that load output. That might be your lights, your fridge, your Wi-Fi. Obviously, in doing that, you're changing the earthing arrangements change, so you wouldn't need an earth rod. But like I say, that output is built into the inverters as standard. The limitations on that output is the rated value of the inverter. So if you've got a 5 kilowatt hybrid inverter, depending on what the battery SOC is and what the PV is generating, the maximum you can take out of that output is 5 kilowatt. Rapid battery charging. So the maximum power you can put into the batteries and take out of the batteries is the rated value of the inverter. So some other manufacturers, if they've got a 5 kilowatt inverter, they might restrict the charge and discharge to the connected batteries to, let's say, 3 kilowatt. But with Sunsynk, it's always the rated value of the inverter. Our hybrid inverters are compatible with solar and wind turbines, and it can be a combination of the two. So if you've got a hybrid inverter that's got 2 MPPTs, you can have one for solar and one for wind. Wind is a lot more complicated than solar. But what gives us the USP on wind is built into our inverter, into the software, we have what's called a 12-point power curve. So wind turbines work similar to a bicycle gear mechanism. So if you imagine if it's not that windy, the turbine the blades will spin quite freely. And what we do at 12 different points is you can set, okay, at this voltage, request this much current, and you can do that at 12 different points. So the faster that turbine spins, the more voltage the PMG is going to create, and we can request more current. So that gives us the USP on that. On and off grid compatible. So off grid is a massive part of the market for us. So we do not need a grid supply. So if someone is completely off grid and they want power, whether it's a room at the bottom of the garden, an office, a new build, with our hybrid inverter and batteries and solar, it will work completely off grid. So yeah, we don't need a grid supply. Backup generator input. So if someone is completely off grid, unless it is a garden bar or something like that, most of the time people will want some sort of redundancy power, and that is always in the form of a backup Jenny. So we have a dedicated input on the bottom of the inverter for a backup generator, and if that backup generator supports ATS, so the auto start signal, our inverter can control that backup generator. So if someone's completely off grid, the only thing they need to do essentially is make sure there's enough diesel in the generator, because they can set our system to say, right, okay, if the batteries get to 30% or 20% SOC, we can send that signal to the Jenny to turn on. The generator power comes into our inverter, and when it comes into us, it essentially splits two ways. It'll go one way to power the load, and it'll go the other way to charge the batteries at the same time. So, if someone was completely off grid before, that backup generator might have been on 18 hours a day, let's say, for however long they needed power. But with our system, because it is charging the batteries and powering the load at the same time while it's on, it might only need to be on for a couple of hours. Quick recommendation on backup generators. We don't have a preferred brand that we work with. Just make sure it's a decent make. And when sizing the backup generator, we always recommend oversizing it a minimum of 150% on top of the size of the inverter. So if you've got a 5 kilowatt hybrid inverter, what you don't want to do is add a 5 kVA Jenny to it, because as I've just mentioned, when that generator power comes into us, it goes two ways. If you've got a max potential load of 4 kilowatt, that 4 kilowatt load is going to take most of the generator power. So, 150% oversized, so an 8 or a 10 kVA generator, that leaves enough headroom to power that maximum load, but also charge the batteries at the same time. Next one, we have an auxiliary output built in. So this works similar to your Eddies and your iBoost. So you can wire, there's an output on the inverter, which you can wire into an immersion. You can set the parameters on the inverter as to what power that immersion heater wants. So this is where we're a little bit different than some of the others on the market, where they will start diverting at, let's say, 200 watts or 250 watts. How our diverter works is you tell the inverter that the immersion wants 3 kilowatt. So if the system is exporting 1.5 kilowatt, what it will automatically do is use the 1.5 kilowatt excess PV, but take the other 1.5 kilowatt from the batteries to give the immersion what it wants, to give it the full 3 kilowatt. And the diverter output control is based on battery SOC. So you might say, okay, only turn that divert on when the battery is at 100%, but turn it off when it's at 97%, 96%. Immersions will take bits of power, but in terms of efficiency, they're most happy when they get the correct power. Next one, all of our hybrid inverters can be AC coupled. So if you've got a customer, whether it's domestic or commercial, and they've got an existing grid-tied system on site, you can leave that grid-tied system there. You don't need to remove it. So, especially for commercial sites, if you've got a commercial building with 500 kilowatt of PV, they might be running that on, let's say they've got 500 kilowatt grid-tied inverters. What you can do with our system is grid connect our system, have your batteries connected to it, and our smart CT will see when those other systems are exporting to the grid. And as soon as our CT sees that export, it will automatically divert it into the batteries. So yeah, domestic over here, a lot of people are on feed-in tariffs still. So they can't change that string inverter. That needs to stay there, but we can AC couple that generation into our inverter. Off-peak charging compatible, so standard. So we've got 6 different time periods on the inverter UI where you can set when you want to charge it from the grid. We've got all the integrations with Octopus in the UK, and there's a lot more to follow. This is mainly for the north, but full G98, G99 and G100 compliance on all of our units. Okay, so the Acure. So as I mentioned at the beginning of the webinar, this is our brand new inverter. This is the stock that Kelleher's will be stocking primarily to start with. So yeah, the Acure, feature-wise, it's the same as the classic range in terms of the basic features. There is some additions. We've got an illuminated LED band on the front of the inverter. So this can be set to show different things, whether it's the load in terms of a percentage of how close you are to the rated value of the inverter, battery SOC. So again, you can have it as a dial to show the current SOC. There's a hinge door on the Acure, which the feedback from installers has been really positive. So, on the classic range, we've got the panel on the front that unscrews and it comes off. This has got a lockable hinge door, so access is easier. And, with the lip that we have at the bottom of the unit, that is hiding when it's wall mounted, the connections underneath. So it makes it look a little bit more sleek. Question we've just had through is the Acure. Yep, so EN 50549 compliance. Yep, fully compliant. Okay, so on the Acure, we've got our brand new user interface. It's sleeker. We've completely redesigned it. We've took feedback from installers. We've introduced sort of quick access controls. And then on the right-hand side image, you can see the power flow. So it will show you what both strings are generating, obviously what's coming in from the grid, your load. If you're using that backup load, the UPS load, because when on grid, that UPS load is powered also. So if, let's say there's no PV being generated and the batteries are at a low SOC, that UPS load is still powered from the grid as a pass-through. It's also showing you what your auxiliary load is doing. We've added some quick access settings like force generator. So on the previous UI with the backup generator integration, you would have to go into the timers and set when you want it to come on. With the new UI, you can quite simply go in and force charge the batteries from the generator, and you can also force charge the batteries from the grid. Full touchscreen display. We've got full slide bars for the control, and yeah, it's nice and sleek. Okay, so the key features of the Acure. So as I mentioned, it's the same features as the standard Eco range, with the addition of, obviously, it looks a bit sleeker, which is nice. The addition of 100% PV oversizing. So I'll come to that a little bit more on the next slide. Available in black and white, so it's a matte black, and we have matching batteries. So the initial stock to Kelleher's is going to be black, which, you know, market feedback has been the most popular. So yeah, matching batteries to suit. The Acure has integrated Wi-Fi, Bluetooth, and LAN connectivity. So as I mentioned at the beginning, we've got different loggers for different comms on the standard range. On the Acure, the Wi-Fi, Bluetooth, and LAN connectivity is built in as standard. IP65 again, so it can be installed indoors or outdoors. Wireless CT compatible, so also inside the inverter, there's a built-in LoRa receiver in the inverter. So we do have a wireless CT solution. So if it is an installation where the inverter and batteries are going in a garage or an outbuilding and you don't want to dig a trench back to the house for the CT, it's fully wireless CT compatible. The LED light bulb, which we've mentioned, and the latest UI, and it's also got built-in arc fault detection, just for peace of mind. Okay, so the low voltage single phase Acure, we will be doing a 3.6, a 5, and a 7. In Ireland, it's predominantly going to be the 5 kilowatt. On the previous slide, we saw the 100% PV oversizing. So on all of the Acure models, you can connect, you know, double the amount of PV over the rated value of the inverter. So on the 5 kilowatt Acure, you can connect 10 kilowatt of PV into it. You've got your max battery charge and discharge on the 5 kilowatt, which is 120 amps. So when you do the calculations on that at 48 volts, it's the rated value of the inverter. And the Acure has got 2 MPPTs with 1 string into each. You can see as we get bigger to the 7 kilowatt, that has 2 MPPTs with 2 strings into each. So the image there shows you the 2 different colors, the black and the white. Okay, so the accessories to go with the Acure, so the wireless CT. So this is the unit you would have at your incoming supply. So it, you know, communicates over the LoRa protocol. 200 meter range, which is conservative. IP65, and they are single and 3-phase compatible. And then we also have the SmartLink. The SmartLink should be with us in the next 2 months. We're just waiting for them to ship. So the SmartLink is your smart sort of diverter, essentially. So if you've got the SmartLink installed, it's got a maximum output of 35 amps. So you can connect that to any sort of AC source, any load, and using the UI on the inverter or the app, you can set rules. So you can set, right, okay, at this SOC, start diverting power to this. Yeah, it's quite intuitive. Okay, so our classic range, we do a 3.6 single phase, a 3.6, a 5, a 7, and an 8 kilowatt single phase. Still single phase, we do a 10, a 12, and we still manufacture the largest single phase hybrid inverter in the world, which is a 16 kilowatt. So the 16 kilowatt is really popular for off-grid installs. So back to what I said earlier on the max power from that UPS load, it is the rated value of the inverter. So if someone is off grid and they've got a decent size load, they're going to need an inverter, sized correctly to be able to power that. So yeah, it's a really popular unit for us, the 16 kilowatt. Max PV input of just under 21 kilowatt on the 16 kilowatt. And the 16 kilowatt, as the 10 and the 12, there's 3 MPPTs with 2 strings into each. So I'm not teaching anyone how to suck eggs, but when you've got an MPPT that's split into 2 strings, that it's really important to make sure both those strings are on the same orientation and both of them have got the same amount of panels. Okay, 3-phase. So we do an 8, a 10, and a 12 kilowatt. So these are low voltage. So when we say low voltage, that's referring to the batteries that they will work with, that we'll come on to in a minute. So yeah, we do an 8, a 10, and a 12. And all of our low voltage inverters, you can easily parallel up to 12 of them together. So, if you've got a massive installation, you can have, I was at a job, I think it was 2 weeks ago, a farm, and they were on a split phase, a split single phase supply. On each supply, they had 12 16 kilowatts connected in parallel, with 150 kilowatt hours of storage connected to each one. So, in terms of finding a solution for a tricky job, yeah, they're really flexible. Okay, so some of the accessories to go with either the Acure or the Classic range. So we've got our battery bus bar. So our batteries, which I'm going to come on to shortly, they come with the cables needed. So that the 5 kilowatt hour batteries, they will come with the long set of 25 mil square cables that will go from the battery to the inverter. And they also ship with the parallel lead, so you can parallel it to the battery next to it. But if you're connecting more than 2 batteries, so 3 or more batteries, we always say to use our battery bus bar. Just if you imagine you've got your inverter and there's 5 batteries connected to it, that first battery is really happy because it's getting all the juice from the inverter. But as we progress down that parallel line, it's quite easy for the batteries to come out of balance. So with our bus bar, you'd have all your batteries connected to the bus bar. So on the long positive and negative leads that come with it, each bus bar will take 5 batteries. If there's more batteries, you can parallel the bus bars. So it comes with like a little copper connection piece. So you can have more bus bars connected together. So yeah, you'd have the included battery cable going to the bus bar. And then from the bus bar to the inverter, that cable size is dictated by the size of the inverter. So if someone's using a 3.6 or a 5 kilowatt hybrid inverter, you will be fine using 25 mil square cabling from the bus bar to the inverter, because the maximum that inverter is going to do, if it's the 5 kilowatt, is 120 amps. But if you're installing much bigger systems, some of the single phase or like a 16 kilowatt, the max charge and discharge rate on the 16 kilowatt is 300 amps. So on the bigger inverters, you would need to size the cable from the bus bar to the inverter to the size of the inverter. So if it's a 16 kilowatt, you might be at 75 mil square from the bus bar to the inverter. So, again, from the bus bar to the batteries, that's fine using the cables that come with it. But from the bus bar to the inverter, you need to size that cable to the size of the inverter. E-strom meters. So all our inverters come with the hardwired CTs as standard in the box. If you don't need a wireless CT, but the run from the inverter to the incoming supply, if it's more than let's say 15 meters, you would typically use an E-strom meter. So we stock these. So we do a single phase E-strom meter and a 3-phase E-strom meter. And these are connected back to the inverter on a full patch lead. So this is just going to avoid any sort of comms or interference issues. If someone tries to extend the included CT to, let's say, 30 meters and they've got it trunked with all the DC or AC cabling, we're going to get a lot of noise on that line. So, those instances, we always say to use the E-strom meter. The 10 taking it back a little step, what I mentioned before about AC coupling, with RCT, if there's an existing grid-tied system, RCT on that main incoming supply will know when the existing grid-tied systems are exporting to the grid, but the data on our screen and our app will be incorrect. Obviously, because the grid-tied systems are, powering the load. The only time the data would be correct on our system is at night when those other systems aren't exporting. So what you can do, you can add an e-strom meter to the AC coupled system, so that connects back to our inverter, and then we put the CT on the AC out from the grid-tied systems, and that our system will sort of intelligently add all the data up, so we can see what the grid-tied inverter is generating. We know what's going to the grid and what the house is using. So yeah, it's not essential to use that, but in terms of having all the data correct, we do recommend it. Okay, so our low voltage batteries, so these are all 48 volt lithium iron phosphate batteries. So we do both a 5.32 kilowatt hour in white and black, and we also do a 10.64 kilowatt hour, again in white and black. So the W series stands for the winter series. So these are designed to charge as low as -10 and discharge down to -20. There is still a level of duration as the temperatures get lower and lower, but they will still charge and discharge. Full life PO4, so really safe chemistry, and you can parallel up to 32 of the W series batteries together. Obviously, you'd never do that with a 5 kilowatt hybrid inverter, but back to what I mentioned, if you've got multiple inverters in parallel, it's really scalable on the battery storage. All of our batteries have got full internal advanced BMS, and they've got a built-in 125 amp MCB built in for isolation. Okay, our high voltage hybrid inverters. So these are obviously 3-phase, and the high voltage now, these will only work with our high voltage batteries. So starting off the range, we do a 20 kilowatt and a 25 kilowatt. You can see you've got the max DC input power there. So 26 kilowatt on the 20 kilowatt and 32.5 on the 25. Each has 2 MPPTs with 2 strings into each, and each has got 1 battery input. And then the 30 kilowatt and the 50 kilowatt. So the 30 kilowatt has got a 39 kilowatt MPPT, and the 50s is bigger in terms of percentage oversize. You can connect up to 80 kilowatt into the 50 kilowatt. And paralleling the high voltage inverters, you can parallel 10 of these. So you can have 10 50 kilowatt hybrid inverters connected in parallel. As you can see on the MPPTs, the larger we go, the more MPPTs we've got. So on the 50, there's 4, each with 2 strings into each. And the 30 and the 50 kilowatt both have 2 battery inputs. So the batteries that they will work with are high voltage batteries. You can see in the images here, we've got there's 2 stacks. Each stack is 61.4 kilowatt hours of storage. So there's actually 12 5.12 kilowatt hour low voltage batteries in that stack. But because when they're connected in series rather than parallel. Once we're at the top, and we're connecting to the BM unit at the top, that's when we're at 600 sort of plus volts. Again, full life PO4, so lithium iron phosphates are really safe. You can parallel, you can connect up to 16 high voltage battery stacks to 150 kilowatt inverter, let's say. So just gives you an idea of the scale of the systems you can create, and that's 16 racks per 50 kilowatt inverter, and you can parallel 10 50 kilowatt inverters together. So yeah, quite endless. Battery configurations. So with all the high voltage hybrid inverters, the minimum amount of batteries connected to each one is 4. So this shows different configurations. We've got 4, 6, and 12. But yeah, the minimum required for the battery startup voltage range is 4. So in the picture on the left, you've got the four batteries, and then at the top, you've got the battery management unit. So the batteries will connect in series up to that battery management unit at the top, and that then connects to the inverter. So yeah, different possibilities. Someone might want to start with 4 batteries, look at some data, and then add more to it at a later date until they, potentially get to a full rack, which is 12. But as I mentioned, the 30 and the 50 kilowatt, they've both got 2 battery inputs. So without using bus bars, you can connect 2 61.4 kilowatt hour stacks to the 30 kilowatt and the 50 kilowatt. But again, you can use up to 16 stacks. So if you're doing that, you would need bus bars, and our tech team would talk you through what that looks like in advance. Okay, so the startup procedure. So this applies to all of our inverters, whether it's a 3.6 kilowatt, a 50 kilowatt high voltage. What we always recommend is, you've got the PV connected, so you've got your MC4s connected, the grid's connected, the battery's connected. Everything's off, so everything's isolated. We always recommend leaving the grid isolated, leaving the PV isolated, and first just introduce the power from the batteries. Because all of our inverters do work completely off grid. The inverter is happy just being connected to the batteries. So once the battery power is introduced to the inverter, the light, the display on the inverter will turn on. And, after a minute or so, the normal light will illuminate above the screen on the inverter. And what that is doing is, rather than turning everything on at once, it's, if there's going to be an issue with comms, typically it's between the inverter and the batteries. So by introducing the batteries first, it lets you sort of just make sure, the comms with the batteries are good. When the screen comes on, when you go into the settings, the bottom right setting, it will say LIBMS. So if you click on that, and if you see positive values on there, so if it's showing you the battery voltages, the temperature of the batteries, you've got good comms. If you click on that screen and you've got a load of zeros, there's an issue with the comms. So you would need to check the patch lead from the batteries. So typically we use CAN protocol, so it would connect from the battery into the CAN input on the inverter. So yeah, if you've seen a load of zeros, just check that connection, and most of the time that will sort that out. This is just showing you the underside of the 50 kilowatt, showing the 2 different battery inputs. As I mentioned, there's 4 MPPTs, each with 2 strings, so you can see you've got all your MC4 connections on the bottom. And back to the first USPs, you've got your 3 main connections. You've got your generator input, your grid input, and your load output. So the load output, that's your UPS output. So that's the whether it's the circuits or any load you want to remain powered in the event of a power cut. Your generator input and your grid. Okay, so we're getting a little bit bigger scale now. I'm not going to cover the big 2-3 megawatt hour containers that we do. But the Power Hub is really popular in sort of agricultural settings. So the Power Hub F120, inside it is essentially a 50 kilowatt hybrid inverter and 2 61.4 kilowatt hour stacks in a self-contained unit. So there's full HVAC, cooling, heating. You've got gas detection, fire suppression built in there as standard. And, these are pretty much plug and play units because the battery racks are all built with the batteries in. All the inverter connections are done inside. The only thing you need to do on site is sort of terminate your final connections into it, whether, grid or PV, and put the batteries into series. So really straightforward. And, the Power Hub, the same as the rest of the range. We don't need PV connecting to our kit. So if you've got a customer who's got off-peak tariffs, or they just want to AC couple an existing grid side system, absolutely fine. No issues whatsoever. Okay, multiple applications. So this is just schematics, just showing the basics of our inverters. So they are hybrid inverters. So they, they will work best when they're connected to batteries, but they will work as a string inverter. So if you've got a customer who is on the fence on, whether they want batteries or not, you can install our inverter, our hybrid inverter, potentially monitor the data for, let's say, 6 months, and then add a battery later down the line. So yeah, it will work as a grid-tied inverter. So with batteries, obviously most common. So this is your split loads, your essential and your non-essential. Obviously, your non-essential loads will be on your main grid-tied consumer unit in the property. But this is showing with that backup load on the UPS terminal, that essentials board. So, whether that is that double socket or, a lighting circuit, yeah, either or. Off-grid. So we've got the backup generator on this one. The generator input on all of our inverters, it can do 3 things, but only one of them at once. So if someone wants to AC couple into our inverter, you can do it the way I mentioned earlier, with leaving the grid-tied system exactly how it is. And just with the CT clamps, we can see when it's exporting. The other way of AC coupling is you can chop the AC feed to that existing grid-tied string inverter and connect it straight into our inverter. And then all the power will pass through us. So that's one of the functions on the generator input. The second one is obviously the generator. And the third function is that diverter. So it'll do, it can do 3 things, but again, only one at once. So you would program the inverter to which one you want to use. If someone is completely off grid and they want to utilize an AC coupled input on the inverter, or they want to use the immersion diverter, we can connect the backup generator grid side, so that can be connected to the grid terminal. The only thing, there's 2 things you need to do if the generator is connected grid side. The first one is you would need a CT coil on the feed from the generator, and that's just to prevent the hybrid inverter back feed into the Jenny, which the Jenny won't be happy with. And on the generator settings page on the inverter, there's a tick box to say that you've connected the generator to the grid terminal. So if you imagine that grid terminal is going to be looking for between 47.5 and let's say 51.5 hertz, whereas that Jenny is going to be outside of those parameters quite a lot while it's starting up. So by ticking that generator connected to grid, what that's doing is it's widening those tolerances. So yeah, quite flexible. AC coupled. So this is with the connecting the existing grid side system. In this diagram, we're showing it on microinverters. So yeah, there's 2 different ways, but the most common way would be to leave the grid side system as it is. Our CT clamp that we've got on the main incoming supply is monitoring that excess. And in addition to that, if you install the e-strom meter, that will tell our system what the grid side system is generating, and all the data will be sort of added together, and it's a lot easier to understand. When someone is AC coupling and they want to add an e-strom meter to monitor the generation on the string inverter, they would need to use a 3-phase e-strom meter. Even if it's a single-phase supply, it's down to the coding on the e-strom meter. Obviously, they would only use 1 CT. But yeah, so if someone does want to monitor that extra generation and tie it into our system, even if it's a single-phase grid-tied inverter, they would need to use a 3-phase e-strom meter. With a wind turbine, so there's a couple of bits missing on this. So with a wind turbine, typically produces 3-phase noisy AC. So that 3-phase noisy AC would then come into a wind controller or a rectifier before it gets to us. And that would change the 3-phase noisy AC to DC, and the DC would then connect into one of our NPPTs. And also built into that wind controller, you would typically have what's called a dump load. So if you imagine with PV, if the battery's full and you're not exporting, the inverter will automatically clip the PV generation. You can't clip wind. So the wind power always needs somewhere to go. So that dump load is typically, a heater, just a big resistive load, and that will dissipate any generated power, excess power, as heat. This is the standard CT. So again, with the single phase inverters, you get one CT in the box as standard. Obviously, three phase, you'd get three. And they would all connect inside the inverter. There's a terminal strip that your CTs will connect into. This is showing you the E-strom meters. So if you are using the E-strom meters, they will connect back to our inverter on a full patch lead. So this is showing you the 50 kilowatt. We've used this image just because obviously it's bigger, it's a little bit clearer. You can see you've got your three different inputs and outputs. So starting off on the left, you've got your UPS connection. So that's your off-grid load. Then top right, you've got your generator connections. And then at the bottom, you've got your grid connection. And then just below all that, you can see there's a common earth at the bottom. And then on the left of the picture, you can see we've got the twisted pairs into the terminal strip, and that's for the CTs. If you're using an E-strom meter, that's obviously on an RJ45 end, and that would go, if you can see, you've got the two yellow cables. These are, one of them is the BMS cable on this one, and the other one is the parallel cable. But if you're using the digital meter, it would go into the left-hand port labeled meter. You can see the terminal strips a little bit closer up there. And again, you've got on the right-hand side, you've got the RJ45 connection. So you've got your meter, so you'd only use that if you're using the E-strom meter. You've got parallel 1 and parallel 2. So this one, obviously having only one parallel lead on, this one would be the master. But if there was three inverters in parallel, the one in the middle would have the parallel in and the parallel out to the one next to it. You've got your CAN communications, so that's your BMS comms from the battery. There's another BMS connection on there as well. Okay, Sunsynk Connect. So this is our monitoring platform. So you can access this on the iPhone app or the Android app store. For you guys as installers, you would have your installer account, and anyone that works for you doing installations, they would have their own Sunsynk Connect account with their own email address, and you add them into your main account as staff. So any installation that they do, those plants will feed into your dashboard. So, you know, back in the office, you can open up the Sunsynk Connect portal on your laptop or your phone, and you can see every installation that's been done for your company. It'll show you all the data, if there's any alarms, any faults. It'll also give you the ability to change any settings remotely if you want to. And also in the app, so in the end user app, I believe we're still the only manufacturer to do this. We've done it for the last 2 years, and it works really, really well. We've introduced a 24/7 live chat facility. So this is with real people. It's not AI. So yeah, 24/7, 365 days a year, the end user can go onto the app. They can click the customer support tab, excuse me, and that will put them through to our team. This works great for you guys as installers because it acts as a firewall in between the end user and you guys as the installer. So if Mrs. Jones wants to, let's say she's moved on to a new tariff and she wants to charge her batteries off peak, rather than her coming to you to get you to remotely log in and do it, the customer can speak to us 24 hours a day, 7 days a week, and we can remotely do that for them. And if the customer is linked to your account, which typically they will be, you guys will get a full transcript of that chat as well. So you can see what's been requested and what was done for the customer. Also on there, I think we're fully connected with Philips Hue. This is a little bit quirky. Some people love it. But with the Philips Hue integration, you can set that to different parameters. So if someone's got a Philips Hue light bulb in the kitchen, they can set that to turn on and go green when the battery's at 100%. So that's a visible sort of signal for them to say, right, the batteries are full. We're now exporting. Let's turn the washing machine on. Let's turn the dryer on. And, they can flip that and set it to go red when they're at a low SOC. So yeah, it's a bit quirky, but some people do find it useful. So yeah, Sunsynk Connect, this is just showing you the power flow. You've got all your graphs, all your stats, daily generation, month, year. You can go into the app and you can dial into every parameter. When you as installers create the plant for the customer, you would go onto your app, you would build the plant on your installer app. You would say to the end user, all they need to do is to create a Sunsynk Connect account. So they don't need to build any plants or anything. They simply just create a Sunsynk Connect account. And then once you've built the plant on your app, you then share that to the end user. And when you share it, it will ask you what access you want to give them. So it'll ask if you want to give them just monitoring or the ability to change settings. So that's down to you guys as installers. But because we've got that 24/7 chat support, do you want end users changing all the settings, or do you want us to look after it for them? But that's completely up to you. And then installers. So on our website, we have a full list of approved installers. The first one is a registered installer. So that's an installer that's done 3 or more systems. Approved installer is 10 or more systems, and a master installer 50 or more systems. So once you get to that stage, you can see the URL at the bottom there. If you just Google Sunsynk approved installers, on that page is a form where you can submit your installations. You would just take a screenshot of your dashboard, which shows you've done 3, 10 or 50. And then on that form, it will ask you for your company logo, address, telephone number, and we will then put you on our approved installer list. Okay, so last but not least, you can see here we've got the Fresh Desk symbol. So our tech support team, if they get asked a lot of questions on one subject, they will typically sort of create a knowledge-based document on that topic. So if you Google Sunsynk Fresh Desk, it will take you to our Fresh Desk platform. You don't need to log into it. And then there's a search facility on there. So whether it's, connecting a system off grid, wiring a backup generator, E-strom meters, if you search that on the knowledge base, 99% of times you will find a knowledge base document on that, whatever you search in, and it will give you a full sort of run through on what you need to do. If you are struggling, our telephone number is on there. That will go through to our main call center, and they will then put you where you need to go, whether it's tech support or pre-sales support. But again, what I mentioned at the beginning of the call is, I know, and, for installers, moving from one brand to another brand, the installation of the inverter isn't really an issue, because essentially they're a big plug socket. It's the commissioning of it, setting up the app. So we're fully aware of that. So I urge new installers to, ring our tech support when you're on site. Just make sure there's comms on it, and just say to them, just say, it's my first installation. Here's the serial number for the inverter. Can you please log into it and let me know everything looks all right? If you did leave site, most things we can fix remotely. But if you've connected the battery comms into the wrong port, or the CTs in the wrong facing the wrong way, there's some things we can't do remotely. So yeah, always pick up the phone on that first installation, just to save you going back to site. So yeah, that's sort of the brief introduction to Sunsynk. We do a lot more. We've got a YouTube channel. There's loads of training videos on there. Again, we're excited. The journey we're sort of undertaking with Kelleher's in Ireland. We will shortly be arranging some roadshows. That'll be at some sort of key Kelleher's branches. So the Damien and his team will be in touch with that in due course. It'll be lovely to meet everyone. Have we got any other questions? Okay, my glamorous assistant, Debbie McGee, has been answering the questions. Can I just have a quick look at them just to see if there's anything that might help other people? Okay, so how many people can connect to the end user app in the home. So as many as you want, so it can be shared to as many users as possible. How quickly does the data refresh on the app? So that can be configured between 60 seconds and 300 seconds. What else have we got? For the generator import, is it possible to charge the battery with a generator without an ATS import if the end user manually started the generator? Yeah, absolutely. So if the generator doesn't have that ATS signal, no issues with going out and manually starting that generator. Yeah, completely fine. But obviously with the ATS, our inverter will turn it on and turn off. But exactly the same rules apply to if it is a manual generator, it's just to make sure it's sized sufficiently to be able to power the load and charge the batteries at the same time. Just looking through if there's any other ones. No, I think we're good. So my colleague Bryony has been answering some of the other ones in the background. So yeah, it's been great to do this. Again, thanks for joining. If there's any questions that you guys have got, speak to your account managers within Kelleher's. If they're unsure of the answers, they can come to me. But yeah, we're looking forward to working with everyone. And yeah, looking forward to seeing everyone face to face when we get those roadshows set up in the future. But thanks for joining again. Have a great day. Cheers.